This is problem 2 for homework 7.1. Determine whether the given set is a subspace. Justify and name the vector space in which it is embedded. Part A. The W contains all the x, y, and z vector, where x minus y minus z is equal to 0, which means x will always be equal to y plus z. We can rewrite the x, y, z vector as y plus z, y, and z. Then split it into two parts, y times 0, 1, 1, 0, plus z times 1, 0, 1. So now the W can be expressed as the span of two vectors. The first one is 1, 1, 0, and the second one is 1, 0, 1. Since it is a span, so it's a subspace by the definition of the span. The subspace W1 is embedded in R3. B. W2 is the set of 2x and 1. Since there are only two vectors in the set, all the linear combinations of 2x and 1 will not be included in W2, so W2 is not a subspace. C. W3 is the span of x minus x cubed. So it is clear that W3 is all the linear combination of the polynomial x minus x cubed. So by the definition of the span, W3 is a subspace and it is embedded in P3 because the highest order of this polynomial is 3. D. S is the set of ax to the 7 plus b, where a and b can be any real number. So we can prove it is closed under addition because ax to the 7 plus b plus another polynomial cx to the 7 plus d will be equal to a plus c times x to the 7th plus b plus d, which has the same form as ax 7 to plus b. So it is closed under addition. Also, by doing k times ax to the 7 plus b, we will get k times a times x 7 plus kb. If we set ka as a coefficient for x to the 7th and kb as another coefficient for the x0 term, then the result will also have the same form as the ax to the 7 plus b, which means it's closed under scalar multiplication. And finally, we have to check the 0 vector, which is 0 times x to the 7th power plus 0, which is just the 0 polynomial. And obviously, it is in the subspace. We have to show that 0 times x to the 7th power plus 0, which should be equal to 0, is one vector in that subset. Finally, we have proved it is a subspace. We know that S is embedded in P7.